Hey there, deep divers. Ready to plunge into a world where code tackles the complexities of legal jargon?
Like taking a legal document as dense as the US tax code and turning it into something a computer can actually understand.
Exactly. That's what we're diving into today. A programming language called Catala, specifically designed to make sense of even the most mind-bending legal texts.
It's fascinating, really. The folks behind Catala realized that legal texts often read like, well, imagine a choose-your-own-adventure book.
Okay, I'm intrigued. How so?
You think you're following the main storyline, then suddenly a hidden clause throws you back to page one.
Uh-huh. Yeah, I've definitely experienced that feeling when reading legal documents. They're like, you need a law degree just to understand the instructions.
Exactly. And it gets even trickier when you try to get computers involved. They need precision, clear instructions, legal jargon, not their forte.
So Catala acts as a translator, bridging the gap between legalese and computer logic.
Precisely. Let's take Section 121 of the U.S. Tax Code dealing with selling your home. Seems simple, right?
You can exclude some profit from taxes.
You got it. But then things get complicated. You can only exclude up to $250,000.
Unless you file jointly, then it's $500,000.
Right. But only if you meet specific conditions. And those conditions, often buried paragraphs later, making the whole thing a logic puzzle.
It's like the law was written in assembly code with jumps. No wonder computers struggle.
And that's where Catala steps in. It uses metadata to define the core concepts and variables that are often implied but never clearly stated in legal texts.
Kind of like creating a legal dictionary for computers.
Exactly. So for instance, in Section 121, the concept of periods is super important for determining eligibility for the exclusion. Catala nails down what a period means in this context, leaving no room for confusion.
No more legal loopholes for computers to stumble over. I like it. But how does it actually transform these legal rules into something a computer could execute?
Well, through definitions and rules, let's stick with Section 121 for now.
Okay, so that rule about needing to live in the house for 2 years within a 5-year window.
Right. Catala takes that statement and turns it into a precise executable rule, defining what owning and using truly means within those specific timeframes.
No more ambiguity, everything laid out clearly.
Exactly. And what's really interesting is that Catala remains declarative.
Meaning?
It's like giving the computer a blueprint of the final dish instead of a step-by-step recipe.
Interesting analogy. So instead of micromanaging, we define the relationships, the legal ingredients, and let the computer figure out the execution.
Precisely. Now, just like any good legal system, Catala also knows how to handle exceptions. Those pesky clauses that say, well, except in this specific case.
Ah, yes, exceptions. The
Yeah.
lawyer's best friend, always adding those extra layers of complexity.
Exactly. And Catala handles them beautifully, like those exceptions to the exclusion amount in Section 121 based on filing status and specific conditions.
Catala ensures the computer makes the right decision based on each unique situation.
That's the idea. So far, we've talked theory. But has Catala actually been used to solve real-world legal challenges?
That's what I'm dying to know. Is it just a cool concept, or is it actually making a difference out there?
Oh, it's making a difference, a big one.
Okay, spill the beans. What have they tackled with Catala?
Well, they used it to formalize French family benefits calculations. It's a notoriously complex system. And get this. During the process, they discovered a potential error in the official government software used to calculate those benefits.
Whoa, hold on. You're saying Catala can find flaws in existing legal systems?
Yeah.
That's incredible.
Exactly. They compared their Catala program to the official state-sponsored simulator. Most cases matched perfectly. But they found a scenario involving a child in social services care that the official simulator didn't even consider.
A blind spot.
Yeah.
And what did Catala reveal?
They dug into the official simulator's source code, part of a project called OpenFisca, and found a discrepancy. Turns out the existing software wasn't correctly applying an income cap exemption for certain families.
So Catala was right. It caught an error that human experts and existing software had missed. Incredible. This highlights the real-world potential of Catala, right?
Absolutely. It's not just about making law understandable for computers. It's about making those systems more accurate and reliable for the people who depend on them.
This is truly mind-blowing. But before we get ahead of ourselves, let's take a step back. How did Catala come about? What were the guiding principles behind its design?
That's a great question. It all started with a collaboration between legal experts and programmers.
So they didn't just throw a bunch of code at the problem and hope for the best.
Not at all. They realized that legal systems, despite their differences, rely on similar reasoning patterns, like that general case exceptions structure we discussed.
Right, starting with a default rule and then layering exceptions on top. That makes sense.
That's a fundamental building block of legal thinking, and Catala was built to mirror that logic.
So it speaks the language of law while being understandable to computers.
Exactly. They even involved lawyers in designing the syntax, choosing keywords that make sense in a legal context.
So it's not just about making the code work. It's about making it usable for the people who actually work with the law.
Precisely. Now, of course, there were some twists and turns in the design process. Early on, they considered a more complex approach to how different parts of the code interact, but
But they realized it was overkill.
exactly. They opted for simplicity, focusing on the core patterns observed in real-world legal texts.
So simplicity and practicality won out.
And to be extra sure about the accuracy of this translation process, they went a step further.
What did they do?
They formally proved the soundness of their compiler using something called the F-proof assistant.
Wait, they mathematically proved that the code does what it's supposed to? Talk about attention to detail.
It's all about eliminating errors, especially in that critical translation phase. Now, the good news is Catala isn't locked away in some research lab.
So people can actually use it.
Absolutely. They've developed a standalone compiler and interpreter written in a language called OCaml, and it's open source, available on GitHub.
So anyone can explore it and even contribute. That's fantastic.
And they put a lot of effort into making Catala user-friendly. They have clear, context-aware error messages.
A blessing for anyone who's ever battled with cryptic error messages in other programming languages.
And the interpreter has built-in debugging tools to help understand how the code executes. Very helpful when you're dealing with complex legal logic.
Okay, so it sounds pretty robust and user-friendly. But what about performance? Can it handle something as massive as, say, the entire U.S. tax code?
Well, they've already tackled French family benefits, which is no small feat. The Catala interpreter handles it well, and when compiled to OCaml, it runs even faster.
So performance isn't a major roadblock.
Yeah.
Now, one last thing that comes to mind is how Catala might fit into existing systems. Most organizations, especially in the legal world, already have their software and databases. Can Catala play nicely with those legacy systems?
Absolutely. Interoperability was a key design principle. They wanted Catala to work seamlessly with other platforms and languages.
So you can actually plug Catala code into existing systems. That's brilliant.
Exactly. They achieved this through direct source code generation. The Catala compiler outputs something called a generic lambda calculus.
A lambda calculus. I'm going to need you to break that down for me.
Think of it as a universal language for computation. It can be translated into pretty much any programming language that supports functions, arrays, structures, and exceptions.
Ah, so it's like a universal adapter for code.
You got it. And they've even demonstrated this with an OCaml backend that can be compiled to JavaScript for web applications.
Wait, so you could have a web app powered by Catala processing legal logic on the fly. The possibilities are endless.
Precisely. This interoperability is crucial when you consider all the diverse systems out there, especially in the legal world.
All right, so Catala seems to have a solid foundation. It's user-friendly, performs well, and can integrate with existing systems. What else have they accomplished with it? Any other real-world applications we haven't discussed yet?
Well, on top of the French family benefits example, there's an ongoing project to formalize the entire U.S. Internal Revenue Code using Catala.
Whoa, tackling the entire U.S. tax code. That's incredibly ambitious.
It is. But they've already made significant progress, having formalized a large portion of Section 121, which, as we've seen, is one of the most challenging sections.
So they're not backing down from a challenge.
And the main takeaway is that formalizing the entire U.S. tax code with Catala is feasible.
It might just take some time and dedication.
Precisely. And remember that bug they found in OpenFisca? That shows how Catala can improve real-world systems, making them more accurate and reliable.
It's like quality assurance, but for the law. Formal verification for legal systems.
Exactly. And beyond the practical applications, Catala opens up new ways to analyze and understand legal texts. Imagine using formal methods to compare different legal systems, identify inconsistencies, or even generate new, more consistent laws.
Whoa, AI helping us write better laws. Now that's a concept worth exploring.
Indeed. But before we get too lost in the future, what do you think is the biggest takeaway from the creation and successes of Catala so far?
I'd say it's the power of collaboration. bringing together legal experts and computer scientists to tackle complex challenges.
Couldn't agree more. Catala is a testament to what's possible when different disciplines come together.
Combining expertise from both worlds to create something truly innovative and impactful.
Precisely. Okay, so French family benefits. A perfect real-world example of how Catala tackles complexity.
I know it's a big part of their social safety net over there, but I can only imagine how intricate those rules must be.
Oh, you have no idea. It's a system that's been evolving for almost a century.
Wow, a century.
Yeah. Countless amendments, adjustments, all codified in 27 articles of the French Social Security Code,
27 articles.
plus various executive orders.
That's a lot to untangle.
It's a lot. So where do you even begin with something that massive?
I wouldn't even know where to start.
Well, just like with the U.S. tax code example, the first step is identifying those core concepts.
Okay, the basic building blocks.
Right. Things like how many children are in the family, ages, incomes, household income, location.
Makes sense.
They even have to consider these specific coefficients that change every year to account for inflation.
So Catala is basically creating a super detailed map of all those moving parts before it even tries to calculate the actual benefit.
Exactly. It's like, gotta have a solid blueprint before you start building.
Right, right.
So once they have all those elements defined, then they can start translating the rules into code.
Okay, so what's the first rule they tackle?
Well, the first step is figuring out which children actually qualify as dependents.
Ah, right, because not every child automatically qualifies, I'd imagine.
Exactly. And of course, there are tons of rules around that. Age limits, income thresholds, special cases for different custody arrangements.
I bet that gets complicated fast.
It does. They have to consider things like alternating custody situations, where a child splits their time between two households.
Oh, yeah, makes sense.
Or cases where a child is under the care of social services. All those nuances have to be accounted for.
So Catala is not just blindly applying a formula. It's actually taking into account all these real-life complexities.
Exactly. It's like it has to understand family dynamics before it can even begin to calculate the benefit amount.
That's pretty impressive.
Huh.
So once they figured out which children qualify as dependents, then what?
Then Catala calculates the base benefit amount.
And is that a simple calculation?
Not really. It has to factor in household income, location with special rules for overseas territories, and that inflation tracking coefficient we talked about earlier.
Wow, so many layers. It's like building a legal layer cake.
That's a good one. And of course, it doesn't stop there. There might be further adjustments based on those custody situations we talked about.
So even more exceptions and special cases on top of the base amount.
Yep. And it's not just about the big picture. Catala has to handle those edge cases too.
Edge cases.
Yeah, like what happens when a child is right on the cusp of an age limit or a family's income is just a tiny bit above a certain threshold?
Right, those little details can make a big difference.
Yeah. Exactly. And the team behind Catala made sure to meticulously account for all those scenarios, ensuring the calculations are completely aligned with the law.
Okay, so they've built this incredibly detailed program that supposedly reflects the French family benefits system perfectly.
Right.
But how do they actually know for sure that it's accurate?
Well, they compared it, of course,
Compared to what?
to the official government simulator used to calculate those benefits.
Oh, okay, so they ran both systems side by side and checked for any discrepancies.
Exactly. And you know what? For the most part, everything matched up perfectly.
Okay, so that's good news. The Catala program passed the test.
It did. But then they stumbled upon this one particular scenario.
What kind of scenario?
It involved a child in the custody of social services.
Okay.
And get this, the official simulator didn't even cover that scenario at all.
Wait, seriously, it just completely ignored that possibility.
Pretty much. It was like a blind spot in the system. So they got curious
Yeah.
and decided to investigate further.
How'd they do that? Did they have access to the inner workings of the government simulator?
Luckily, they did. The official simulator is part of this project called Open Fisca, and the source code is publicly available.
Oh, so they could actually look under the hood and see what was going on.
Exactly. And when they dug into the Open Fisca code, they discovered something interesting. A discrepancy.
A discrepancy, you mean like a mistake?
Potentially, yeah. It turned out that Open Fisca wasn't properly applying an income cap exemption for certain families.
The kind of families.
Single-child families in overseas territories.
So a very specific case, but still a case that the official system was mishandling.
Exactly. It was a tiny detail buried in the legal text, but Catala caught it because it was programmed to meticulously follow every rule and exception.
Wow, so Catala not only translated the law into code, it actually found a flaw in the existing system.
That's the beauty of it. It's like having a second set of eyes, a superpowered legal expert double-checking everything.
Incredible.
Yeah.
So it's not just about making the law understandable for computers. It's about using that understanding to improve the systems we already have.
Precisely. And that's just one example. Imagine the potential for improving other areas of law, like tax codes, environmental regulations, even criminal justice.
The possibilities are mind-boggling.
Hmm.
But before we get carried away with all the potential applications, let's focus on this French family benefits case for a moment.
Sure.
What else can we learn from this experience? What does it tell us about the benefits of formalizing law with Catala?
Well, aside from uncovering potential errors, it also highlights the importance of transparency.
Transparency.
Right. You see, the Catala code for French family benefits isn't some big secret. It's publicly available as an OCM in the library.
Yeah.
And it even powers a web-based simulator that anyone can use.
Wait, so anyone can actually see the code and understand how the calculations are being done?
Exactly. No more black boxes or hidden formulas. It's all out in the open.
That's incredible. It's like democratizing the law, making it accessible and understandable for everyone.
That's the idea. Transparency builds trust, and it empowers people to understand how decisions are being made.
Right. So we've gone from translating law into code to uncovering errors and now promoting transparency. It's amazing to see how far this technology has come.
And it's just the beginning. There's so much more we can do with Catala. But before we dive into other examples, I think it's important to address the question of adaptability.
Adaptability.
Yeah. Can Catala really handle the unique challenges of different legal domains and systems? That's something we'll explore in the next part of our deep dive. So can Catala handle, say, contract law, intellectual property?
Yeah.
Those fields have their own unique jargon and logic.
Right. It's not like you can just copy-paste the same code from tax law and expect it to work for everything.
And that's what's so cool about Catala's design.
Okay, how so?
The creators knew from the start that legal systems are incredibly diverse.
Yeah.
What works for one type of law in one country might not work for another type of law in a different country. So they didn't try to create a language that was specific to any one domain.
So instead of focusing on the specifics, they went for a more fundamental approach.
Exactly. They focused on those core principles of legal reasoning,
Okay.
those underlying patterns that you see in pretty much every legal system.
Like what?
Well, remember that general case exception structure we keep talking about.
Yeah, starting with a general rule and then adding all those exceptions and special cases.
That's a fundamental concept that you see everywhere, no matter what type of law you're dealing with.
Right. It's like building a legal decision tree.
Exactly. You start with a trunk, a general rule, and then you add branches for all those exceptions based on specific conditions.
And Catala was designed to mirror that structure.
That's right. It provides this framework for expressing those legal decision trees in a way that's both precise and, easy for humans to understand.
So lawyers can use Catala to formalize their own areas of law, no matter how specialized or niche they might be.
Exactly. And, they've already demonstrated this flexibility in several ways. Remember how they had to integrate, dates and durations into Catala to handle those time-based rules in the U.S. tax code?
Right, defining what a year actually means in that specific context.
That's a perfect example of how they can tailor Catala to the specific needs of a particular legal domain. And they've also experimented with different ways of handling those scope overrides, making sure they find the best balance between flexibility and, making the language easy to use.
So they're constantly refining Catala, making it more adaptable and powerful.
That's the goal. As they formalize more and more areas of law, they're learning what works, what doesn't, and constantly making improvements.
That makes sense. So big picture time.
Yeah.
What do you think the success of Catala tells us about the future of law and technology? Where are we headed with all of this?
I think it's a clear sign that the gap between law and technology is shrinking.
Yeah.
We're moving towards a future where legal systems are no longer these big, mysterious black boxes,
Right.
but they can be understood, analyzed, and even improved using the tools of computer science.
So we could see things like automated legal processes, more efficient dispute resolution, laws that are written with much more clarity and consistency from the start.
Exactly. Catala is a huge step in that direction.
And as AI and machine learning continue to advance.
Well, the possibilities are pretty much endless. We could be looking at a future with a much more just, transparent, and efficient legal landscape.
That's a really exciting thought. Now, before we wrap up this deep dive, I have to ask you one more question.
Go for it.
If we can already translate law into code, do you think AI could one day actually help us write those laws in the first place?
Ooh, that's a big one. That's taking it to a whole other level.
It is. I mean, we've talked about translating law, finding errors in existing systems, but actually writing new laws with AI. That opens up a whole new can of worms.
It does. I mean, think about the ethical implications, the potential biases that could be baked into the algorithms. It's definitely something that deserves a lot more thought and discussion.
It's a future full of possibilities, but also potential pitfalls.
Exactly. And that's what makes this whole field so fascinating. We're not just dealing with technology, we're dealing with the fundamental questions of what it means to be human, how we make decisions, and how those decisions shape our society.
Well said. Deep divers, I think it's safe to say we've emerged from this deep dive with a whole new appreciation for the intersection of law and code. We've seen how Catala, this amazing language born from collaboration and a deep understanding of legal reasoning, is making a real impact on this field.
And as this technology continues to evolve, who knows what the future holds? But one thing's for sure, it has the potential to transform legal systems worldwide, making them more transparent, efficient, and accessible for everyone.
If you're interested in exploring Catala further, we've included a link to their GitHub repository in the show notes. And in the meantime, keep pondering that question about AI and the future of lawmaking. It's a conversation that's just getting started, and we'd love to hear your thoughts.
And until next time, keep exploring, keep questioning, and keep diving deep into the world of knowledge.